Okay, so today we're going to look at section 3.11, geometric sequences. One of the current concerns when investing is the doubling time, which is the length of time it takes for a value of the investment to be twice or double that of its starting value. We know what a sequence is, but what makes a sequence a geometric sequence? In an arithmetic sequence, each term is the previous term plus the constant difference. So you add a possible negative number at each step. In a geometric sequence, though, each term is the previous term multiplied by the same specified value called the common ratio. For each sequence, determine if the sequence is a geometric sequence. If so, identify the common ratio. So what's happening here? I'm multiplying by 4, but here I'm multiplying by 5. So not. Okay, let's see what's happening here. Negative 3 times negative 2 gives me 6. 6 times negative 2 gives me negative 12. Negative 12 times negative. So this is, and it is negative 2. Here I have 500. If I divide it by negative 10, I have 50. If I divide that by negative 10, I have negative 5. So yes, and instead of dividing, we're going to say 1/10. Okay? So, as with arithmetic sequences, the first term of a geometric sequence is labeled a sub 1. The number that is multiplied by each term is called the common ratio and is the r. So if the first term is known, a1, and the common ratio is known, r, then the nth term, a sub n, can be calculated with the formula a sub n equals a sub 1 times r to the n minus 1. Okay, and that's what the formula here says. A sub 1. Is that a 1? Nope, that's an I. The following geometric sequence determine the indicated term of the geometric sequence with a given first term and common ratio. So we want to know, determine the 12th term of the geometric sequence with a sub 1 equal to 3072 and r equal 1/2. So a sub 12 is equal to a sub 1, 3072 times 1/2 to the 12 minus 1. So again, on your calculator, you're going to look for ideally a caret button. Because what we're looking at here is 3072 times 1/2 to the 11th power. So we can take it, and we know 1/2 using our calculator, 0.5. So we would put 0.5, then this caret button, then 11, and then equals or enter, depending on your calculator. So 0.5 caret 11. And we're going to get a scientific notation number. Then we take that and multiply it by so what I get is 4.082825 times 10 to the negative 4. If I take that and multiply it by 3072, I get 1.5. Okay, so to determine the fifth term of the geometric sequence A1 equal 0.5 and R equal 8. So A sub 5 is equal to 0.5 times 8 to the 5 minus 1, which is 0.5 times 8 to the fourth. Well, 8 to the fourth, 4,096 times 0.5 gives me 2,048. Okay, as with arithmetic sequences, it is possible to add the terms of the geometric sequence, like arithmetic sequences. The formula for the finite sum of terms of a geometric sequence has a straightforward formula. The sum of the first n terms of a finite geometric sequence, written S sub n with first term a sub 1 and common ratio r, is S sub n equals a1 times 1 minus r to the n minus 1 over 1 minus r. So, what is the sum of the first 10 terms? The thing here is we don't need the 10th term. We don't need the nth term. We did when we did the arithmetic sequences. So here we have a1, so s sub 10 equals a1, which is 7, times 1 minus r, which is 6, to the 7 minus 1, all over 1 minus 6. Now this is 7. I have 1 minus 6, the 6th power over -5. Using my calculator, 6 to the 6th power gives me a whole lot, equals 1 minus 46656 -5. Oops, I forgot something. 7 times. So we have 7 times -46655 divided by 5. So if I divide by 5, I get -5, sorry. That gives me a positive 9,331. Multiply that by 7, and I get my final result is 65,317. Okay, what is the sum of the first 6 terms of the geometric sequence with first term a1 equals 27 and common ratio 1/3? So I have 27 times 1 minus 1/3 to the 6 minus 1, which is 5th, over 1 minus 1/3. Or 1/3 to the 5th is 1 over 243. Or it's better to leave this as a fraction for now. 27 times 1 minus 1 over 243. And this is simply 2/3. I have 27 equals, this becomes what, 242 over 243 over 2/3. So if I take 243 and divide it by 3 is 81. So if I multiply this fraction by 81 over 81, I end up with 27 times 242 over 243 over 162 over 243. With a complex fraction like this, when I have the same denominator in the fraction and the numerator as in the denominator, I can just ignore them. It becomes 27 times 242 over 162. And at this point, I can just do the multiplication. 27 times 242 divided by 162 equals, and this ends up being 40 and 1/3. Calculator shows 40.33 repeating, which is 1/3. Okay, so let's look at some real world applications of this. If you deposit P dollars in an account that earns interest compounded yearly, then the amount in the account A after T years is calculated with the formula A equals P times 1 plus R to the T power. This is a geometric sequence with a constant ratio of 1 plus R in the first term, A1 equals P. So let's rewrite that over here so we'll have it as we change the page. So Sophia deposited $4,000 in an account that earns 5.5% interest compounded yearly. After 20 years, Sophia withdrew the money in the account to pay her child's college. How much money was in the account when Sophia withdrew the money? So our P is our principal amount, the amount she started with, 4,000. Our interest, our R, is 5.5%, but we need it in decimal form of 0.055, and our T in this case is 20 years. 4,000, 5.5, 20 years. So we have everything we need for the formula. A equals 4,000 P, 1 plus 0.055 to the 20th power. Well, following PEMDAS, parentheses first, 1.055 to the 20th, exponents next, so again, 1.055, hit your caret button, 20. 1.055 to the 20th power. And I get 2.9177577491. And we're going to multiply it by 4,000 to get 11,671.02996. Seeing as how this is money, that's a 2. We're looking at the second decimal place. Looking here, I round up, so I have $11,671.03. Okay, next up, the Streptococcus lastus, or X lactis, is in a milk culture at 37 degrees Celsius. The population of S. lactis doubles in number every 30 minutes. If the culture began with 15 organisms, how many S. lactis bacteria are present in the culture after 20 minutes? Okay, so this should be hours. So let's look at this. A sub 1, A sub 1 is 15. Our doubling time is 30 minutes. So 20 hours is going to give us 40 time periods. So we're looking for A sub 40. Our rate is doubling, so it's 2. And if I remember correctly, that's all we need. Double check this formula. S sub n equals A sub 1, 1 minus r to the n minus 1, 1 minus r. I'm looking for S sub 40 equals 15 times 1 minus 2 to the 39th power over 1 minus 2. So 2 to the 39th power is going to be quite a bit. 2 to the 39th power. Uh, 2 to the 39 equals 5.497558139 times 10 to the 11th. Okay. So I'm going to get 15 times 1 minus that, which is going to be kind of hard to write. So I'm just going to do 1 minus that over negative 1. So minus 1 divided by negative 1 times 15. And we end up with roughly, okay, I've got 10 to the 12th now. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's as far as my calculator goes. 10, 11, 12. So what are we looking at? Thousands, millions, billions. 8 trillion over 8 trillion. Quite a few. You have a square meter on each, a square 1 meter on each side. You begin by coloring 1/2 of the square blue, then you color half the remaining area blue. Then you color half the remaining area blue once more. At each step, you color half the remaining area. I think that's a subtle hint. R is 1/2. A sub 1 is 1. The total area you have colored after performing 15 times. So N is 15. So we're looking for S of 15 equals 1 times 1 minus R 1/2 to the what? 15 minus 1 is 14th power all over 1 minus 1/2. So I have 1/2 on the bottom here and 1/2 to the 14th. Okay. So I have 1 minus 1 over 16384. which gives me 16383 over 16384 over 1/2. If I multiply by 2 over 2, this and this go away, and I have 3276 6 over 16384, which doesn't make sense because that is more than the whole thing. So let's look at this again and see where we messed up. Start from the beginning. What do we know? I think I know where I messed up. You begin by coloring 1/2. So a sub 1 equals half. Have to be careful. It's easy to get stuff mixed up with these. And we already said our rate is 1/2. And we know that n is 15. So S sub n equals 1/2 times 1 minus 1/2 to the 14th over 1 minus 1/2. A lot of 1/2s in here. So again, we have 1/2 times 1/2. We have 1 minus 1/2 to the 14th. Now, here's the interesting thing. 1/2 times something over 1/2, these cancels out. So now I'm left with 1 minus 1/2 to the 14th power, which we had equals 1 minus 1 over 16384. So it's 16383 over 16384. Almost completely done. But doing it this way, you'll never get complete. And that, I believe, finishes section 311 on geometric means, as well as chapter 3.